All right. Good morning, everybody. So it is Monday morning. Is it the 16th? Yeah. No. Yeah. 16th. 11/16. Okay. So today, more geometry, and the book always makes this thing so darn hard because they don't draw the circle. So what are we talking about? Let me go ahead and teach. Today, what we're going to talk about is constructing this thing called the in-center. Let me highlight in-center. In means inside. Okay. But what we're going to do is put a circle inside, and that's what makes this lesson easy, is if you draw the circle. So we're going to put a circle inside a triangle. So here's my triangle. I want to put a circle inside, but it'd be nice to know where the center is. We need the center. So what we need to do is find the center of the circle. So the center of the circle, how do we do it? Well, if you find the angle bisectors, all three angles, angle A, angle B, and angle C, if we bisect or cut the angles in half, they'll all come together in a single point. So watch me do it, okay? Here we go. All right, so I'm going to measure this angle, and I can divide by 2. So angle bisector. So if I put my protractor like this, zero it out, now I've got about 40, maybe 44 degrees, half 44 degrees, so that's about 44 degrees. Half of that's 22. All right, so let me go ahead and do a 22-degree angle like this. 22 is right about there. If I draw that in, boom. Okay, there's my angle bisector. Okay, now let's do angle C. So angle C, let's see angle C. If I go ahead, and angle C is about 72 degrees, and half of that's 36, right? 72 degrees, half of that's 36 degrees. All right, so let's see, 36 degrees right about there. Use my protractor. And then I'm going to go ahead and do that. And then finally, this one here, angle B, I can measure that. And let's measure it this way. Hopefully my head's not in the way. You never know. About 66, and half of that would be 33. 66, and half of that is 33 degrees. And if I measure 33 degrees, half of that is 33 is right about there, and sure enough, it seems to go right through there. Okay, so what we've created is a point, and that point is called the in-center. That point is called the in-center, but big deal. So what? So let's draw it in a circle. So get the protractor out, and it's got to be inside. So what happens is if I draw it inside like this, there's my center, and if I don't always do it, okay, I should be able to put a circle on the inside of this, so I did it right, okay? Yeah, it looks to me like I might be off by a little bit, but you never know. Could be off by a little bit. Oh, I'm off. Anyway, all right, Mr. Davies should go a circle like this. Oh, terrible. All right, anyway, you got the idea. I'm not a very good artist, but, you know, so there you go. There you go. Oh, my goodness, sorry, guys. All right, there we go. Now, once you put the circle in, there's a few things that seem really obvious to me, okay? First of all, you have to be able to draw a circle, but obviously I can't. What we find out is that this right here, this line right here, straight down, and this line right here, straight across, and this line right here, straight across, those lines are all perpendicular, and they're all equal. That's equal to that, which is equal to that, because they're all radii of the same circle. Let's write that down. So let's label these. Let's label these X, Y, Z, and we'll call that point P. So XP is congruent to YP, which is congruent to ZP, because they're all going to be radii of the same circle. They're all radii, okay? So the in-center is made by angle bisectors, and it's the point that helps us draw a circle. Find this the center of the circle that's inside a circle, okay? Got it? Now, when we take a look at number 9, this one right here, construct the circumcenter. Okay, so the circumcenter, to do that, we need perpendicular bisectors. Okay, so then let's see, perpendicular bisectors. I need a good ruler. This one's a piece of credit ruler. Hold on, let me get a good ruler out real quick. All right, one that actually can measure. So perpendicular means middle. bisector means middle, and perpendicular means 90. So let's see. That's about 7.4 maybe. Half of 7.4, right? 7.4 divided by 2 is about 3.7. Right? So now this line is straight up. Doesn't go through this point, straight up. Okay, that's equal to that, and that's 90. Okay, let me do it again. So this is, turn my paper this way, it might be easier if I turn my paper this way. About 6.4, and half 6.4 is 3.2. Come on in, writer, I'm almost done. 3.2, there it is. So I'm going to draw this straight up. 90 degrees, okay? Boom. Does not have to intersect there. That's equal to that, and that's 90 degrees. And then finally, the other one, it's got to be right here, okay? So we've drawn, I've got it for you right here. Let me get started. And then I'll help you. I'm almost done, right? Okay, and your old one is right, I have it laying around, oh, it's right there. The old one's right there, okay? So then if I draw all those, that's equal to that. Of course, I didn't draw very well, but if I draw it right, these are perpendicular, and they cut it in half. Perpendicular, cut it in half. I think I missed that one. That's right. So what we get then is the center of a circle, and it goes outside, circumscribed, so the circle is going to be outside. So let's see if I can draw that. And of course, I'll do this in class as well because, you know, I'm never very good at this, but if I draw the circle on the outside, it should touch all the way around. Oh, you know, I'm off by a little bit. I'm off by a little bit. Yeah, I'm off by a little bit. Well, you know, maybe in class I'll do a better job. All right, there you go. Oh, terrible job as always, but you know. So we do, oh, you missed there, is I got a circle. Yeah, there's a circle right here. Let me draw it by hand. Here's a circle. We found the center of the circle. And the center of that circle is called the circumcenter. That point there, called P, is a circumcenter, okay? And what it does is it allows us to draw a circle around the triangle, okay? Now, what we don't see in this drawing is this. I'm going to draw it in so you guys can see it. This line, draw it in dark red. This line, and this line, okay? Now, those are all radii of the same circle, okay? So let's label those. Okay, again, I'm going to probably go, I've got triangle A, B, C, and that's P. So what do I know? Well, I know that AP is congruent to BP, which is congruent to PC, okay? They have to be because they're all radii of the same circle, so those are equal, okay? Now, what we've done is created the circumcenter. All the radii are equal. We've made a circle around the triangle, and we know that these segments are equal. Now, if you go to what the book does, let me show you some examples of what the book does, okay? Kind of what your homework is all about, is they don't draw in the circle, and it really helps a lot. So if these are angle bisectors, okay? Right, so they don't draw in the circle, and if you drew in the circle, it makes it so much easier. But if it's an angle bisector, then we're looking at the circumcenter. Angle bisectors, circle's inside, right? So if I draw that circle inside, okay, then if I put the circle inside, oh no, these are perpendicular bisectors, ABC, sorry. So if I drew the circle on the outside, and I'm not going to draw a very good circle because I'm not much of an artist, then we know that these are radii of the same circle. Okay, I'm going to highlight that, okay? I like the circle in it, so if I highlight it, then I know that is equal to that, which is equal to that, right? And if they're bisectors, then this side's equal to this side. That's 8 and 8. That's 9. Here, let's put this in, okay? Let's put it, okay? Here we go. That's 8, then that's 8. If that's 9, then that's 9, which means that's 9 because they're all radii of the same circle, okay? Now, point G, so triangle XYZ, as this one, is angle bisector. So that's the case, and we got the circle on the inside. Now, you don't really see the circle, but if I draw the circle on the inside, it helps. So I know these all have to be equal. So if that's 2, then that's 2, and then that's 2, okay? And that's all we know. So if you want to find PS, well, that's just 2, okay? Number 4, if if you're going to draw it, I'm going to do number 4. I'm going to do number 4 on a piece of graph paper. And again, we'll do this in class. But let me go ahead and draw this in. And do this. Okay, so let's draw it in. Okay, so graph 6, 0. 1, 2, 3, 4, 5, 6. There's J. 0, 0 is K, and 0, 4 is L. So I've got a triangle in here. Let me go ahead and draw in my triangle so you guys can see it. There's a triangle, 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 okay? So what we want is circumcenter, okay? So let me look at my notes. Circumcenter. Okay, circumcenter is the perpendicular bisectors. Okay, so, all right, draw those in, perpendicular bisectors. Let me give it a different color. So I'm looking for perpendicular bisectors, all right? Perpendicular bisectors, okay? What does that mean? Well, bisector means cut in half, like right there, and at 90 degrees, okay? Cut it in half, and at 90 degrees. I can do that. Okay. Okay. Bisect it, it's right there, cut it in half, and 90 degrees. It's right there. Well, I already found it, right? And my guess is with this side, it's going to be the same thing. It's going to look like this, perpendicular. But either way, there is your circumcenter, which is at the point 3, 2. And again, we're going to talk about this more during Zoom, but that's what I have. Again, in the homework, if you draw the circle in, it makes it so much easier. Okay.